Hello everyone. So far in this series, we have explored how large language models actually work. We talked about tokens, embeddings, attention, transformers, and how models generate text. Now, before we move into topics like retrieval augmented generation, fine tuning, AI agents, and model context protocol, we need to pause and ask an important question. What are the limitations of LLM? Because while modern AI models can do some incredible things, they can write essays, answer complex questions, generate code, even summarize large documents in seconds. It almost feels like the model knows everything, but the truth is very different. Every large language model has fundamental limitations, and understanding these limitations is extremely important if we want to build real world AI systems. Let's explore them. Limitation 1, knowledge cutoff. The first limitation is something called a knowledge cutoff. Large language models are trained on massive data sets collected from the internet, books, articles, and other sources. But this training happens at a specific point in time, which means the model only knows information up to that moment. Anything that happens after that point, the model simply does not know. For example, new research papers, recent news events, updated documentation, latest software versions, new technology releases. If this information was not part of the training data, the model cannot know it. In other words, the model's knowledge is frozen in time. Here, for example, I have shown it as 2021. Limitation 2, hallucination. The second limitation is one of the most well known issues in AI today. It's called hallucination. Large language models generate text by predicting the next token in a sequence. They are extremely good at producing language that sounds convincing. But here the point is they are not verifying facts. So when the model doesn't actually know the answer, it may still try to produce a response. And in doing so, it might invent details, fabricate references, produce incorrect explanations. The response may sound very confident and very convincing, but in reality, it could be completely wrong. This phenomenon is what we call AI hallucination. Limitation 3, no access to private data. The third limitation becomes especially important in enterprise environments. Large language models are trained primarily on public data, which means they do not automatically know anything about your organization's internal information. For example, your company documents, internal databases, private knowledge bases, or personal files. All of that information exists outside the model. Without additional systems connecting the model to these data sources, the LLM simply cannot access them. And that makes many real world business applications difficult to build using only LLM. No real world interaction. The fourth limitation is about action. A language model can generate text, but it cannot actually do things in the real world. For example, it cannot query a database, call an external API, send an email, run a business workflow, or interact with external software tools. On its own, an LLM is purely a generative system. It produces language, but it cannot take actions, which means by itself it cannot power most real world automated systems. So, here is a big insight. Large language models are incredibly powerful. The transformer architecture behind them is one of the most important breakthroughs in modern AI. But by themselves, LLMs are closed systems. They cannot access new information, they cannot use private data, they cannot perform real world actions, and they cannot dynamically update their knowledge. So, how do we solve these problems? Modern AI systems solve them by augmenting LLMs with additional architecture. Techniques like retrieval augmented generation or RAG, fine tuning, tool use, AI agents, and model context protocol or MCP. These approaches connect the language model to external knowledge, tools, and systems. And that is what transforms a simple language model into a powerful real world AI system. In the upcoming episodes, we will dive deep into each of these topics and see exactly how modern AI applications are built. So make sure you stay tuned. If you found this video helpful, please like the video, subscribe to the channel, and share it with others who want to learn AI in a clear and simple way. And I'd really love to hear from you. Leave a comment with your feedback on this video and let me know what AI topics you would like to see next. The next episode, we will start with one of the most important architectures in modern AI systems, Retrieval Augmented Generation or RAG. See you in the next video. Until then, take care.